In the sunlit fringe of the cosmos, Earth sings a melody while mining the rays, a cosmic dance of celestial fragments woven into our tale at the crossroads of time, embarking on an infinite adventure sparked by stars showering down. Seeking the clues of the universe, we set forth, carrying dreams in our hearts, a tiny part of the Milky Way, where suns and planets scatter far and wide. Born from the primordial dance, we, the precious children of the cosmos, as Earth's essence radiates amidst the azure undulations, unveiling new doors in the enigma of the universe, transcending boundaries on the challenging cosmic journey. The future perched on Earth's shoulders, guided by the whispers of the stars, eternal wanderers drifting through space, our roots deeply planted in the cosmic embrace. In the radiant glow of the sun, we script a new narrative. O universe, as we dance with you, our existence trembles to the celestial hymns. From the solar system, our odyssey commences. Our lives become the universe's verse. Our stories echo as a song flowing from the boundless cosmos. Hello. Today, let's embark on a journey exploring humanity's quest towards the solar system and beyond, delving into the challenges we face and delving deeper into the Sun, Mercury, and Venus. Your subscriptions, likes, and notification settings greatly empower our video production. The solar system refers to a system composed of the Sun, a G-type main sequence star at its center, and celestial bodies gravitationally bound to it. The constituents of the solar system include Sun, the central star of the solar system, accounting for 99.86% of the total mass. The Sun undergoes nuclear fusion, converting hydrogen into helium, and emits tremendous energy and light. Planets. 8 planets orbit the Sun. They are categorized into inner terrestrial planets, Mercury, Venus, Earth, Mars, and outer gas giant planets, Jupiter, Saturn, Uranus, Neptune. Terrestrial planets, Mercury, Venus, Earth, and Mars have solid surfaces. Mercury and Mars have thin atmospheres, while Venus and Earth have thick atmospheres. Earth is unique for having liquid water and supporting life. Gas giant planets. Jupiter and Saturn are mainly composed of hydrogen and helium, while Uranus and Neptune contain water, ammonia, methane, and other compounds. Gas giants have thick atmospheres and distinctive ring systems. Dwarf planets. Celestial bodies similar to planets, but smaller and haven't cleared their orbits. Examples include Ceres, Pluto, Haumea, Makemake, and Eris. Asteroids. Small celestial bodies with planet-like properties, but irregular shapes. Asteroids are found in the asteroid belt between Mars and Jupiter, the Kuiper belt beyond Neptune, and the scattered disk. Comets. Small bodies made of ice and dust that develop tails when approaching the Sun. Comets originate from the Oort cloud or the Kuiper belt and orbit the Sun. Moons. Satellites. Natural satellites that orbit planets or dwarf planets. The largest moon is Ganymede, which orbits Jupiter. Meteoroids. Small burning celestial bodies entering a planet's atmosphere are called meteoroids. They can originate from asteroids or comet fragments. The formation and evolution of the solar system began approximately 4.6 billion years ago. It originated from a massive cloud of gas and dust in the central region of our galaxy. Gravity and rotation caused this cloud to contract and spin, forming a disk. The Sun formed at the disk's center, while planets and other celestial bodies formed in the outer regions. The early solar system experienced significant collisions and changes, influencing the size, shape, orbits, rotation, atmosphere, and surfaces of the planets. Hello, I will introduce the history and exploration of space probes. A space probe is an unmanned spacecraft created by humans to explore outer space. Space probes study various celestial bodies in the universe, including Earth's orbit, the Moon, planets in the solar system, asteroids, comets, dwarf planets, and even phenomena like wormholes. They collect information on the origin and structure of the universe, its physical properties, and the potential for the existence of life. The history of space probes began on October 4, 1957, when the Soviet Union launched Sputnik 1, the world's first artificial satellite. This event triggered the space race between the United States and the Soviet Union. On January 2, 1959, the Soviet Union launched Luna 1, which entered solar orbit, becoming the first spacecraft to reach the vicinity of the Moon. Luna 2, launched on September 12, 1959, became the first artificial object to impact the Moon's surface. In the 1960s and 1970s, both the United States and the Soviet Union launched various space probes to explore the Moon and planets in the solar system. Notable missions include Ranger 1, which captured detailed images of the Moon's surface in 1961, and Mariner 4, which approached Mars in 1964, providing images and measurements of its atmosphere and magnetic field. The 1969 Apollo 11 mission marked the first human landing on the Moon, with astronauts Neil Armstrong and Buzz Aldrin walking on its surface. Apollo 12, launched on November 10, 1969, collected lunar material and met the unmanned Surveyor 3. In the 1970s, both superpowers launched probes to explore the outer planets. Pioneer 10, launched on March 2, 1972, approached Jupiter, studying its atmosphere, magnetic field, rings, and moons. Pioneer 11, launched on April 6, 1973, approached both Jupiter and Saturn, providing valuable data on their characteristics. In the 1980s and 1990s, other countries joined space exploration efforts. The European Space Agency, ESA, launched Giotto 1 on July 5, 1985, which approached Halley's Comet. In the 2000s and 2010s, the United States and the ESA, among others, continued to explore various targets in the solar system. Mars Odyssey, 2001, Mars Express, 2003, Spirit, 2004, Cassini-Huygens, 2004, New Horizons, 2006, Curiosity, 2011, and Rosetta, 2014, are some of the missions that explored Mars, Saturn, Pluto, and comets. In the 2020s, China, India, the UAE, and others launched space probes. Notable missions include China's Tianwen-1, 2020, and Chang'e 5, 2021, the UAE's Hope Probe, 2020, and NASA's Perseverance, 2020, and Ingenuity, 2021 missions to Mars. Space probes contribute significantly to humanity's understanding of the universe, providing crucial information on its origin, structure, physical properties, and the potential for life. These remarkable technological achievements realize human dreams and aspirations in exploring the cosmos. The Sun is a star located at the center of the solar system, and it is the closest star to Earth. The Sun emits light, heat, and solar wind into the space between all the planets, moons, comets, and asteroids in the solar system, exerting gravitational dominance and controlling their movements through universal gravitation. The Sun is a hot and massive ball of gas, with a core temperature of about 15 million Kelvin, while its surface temperature is around 6,000 Kelvin. With a diameter of approximately 1.39 million kilometers, the Sun is about 109 times larger than Earth and has a mass of 2x 10^30 kilograms, making it approximately 333,000 times more massive than Earth. Its volume is also about 1.44 million times that of Earth. Consequently, the Sun accounts for about 99.86% of the total mass in the entire solar system. About 75% of the Sun's mass consists of hydrogen, and the remaining 25% is primarily helium, with less than 2% composed of heavier elements like oxygen, carbon, neon, and iron. The Sun undergoes nuclear fusion reactions in its core, converting about 4 million to 6 million tons of hydrogen into helium per second, releasing tremendous energy and light in the process. The Sun's hot corona extends continuously into space, generating the solar wind, a stream of charged particles that reaches approximately 100 astronomical units, forming the heliosphere. The heliosphere is a bubble-like structure created by the solar wind in the interstellar medium, and it is the largest structure within the solar system. Although the Sun emits white light, it may appear yellow on Earth due to atmospheric scattering, especially the blue light. The Sun is approximately 149.6 million kilometers, 1 astronomical unit, away from the Earth. But to be exact, the Earth reaches perihelion in January and is closest to the Earth, and in July, it reaches aphelion and is furthest away. It takes approximately 8 minutes and 19 seconds for light to travel from the Sun to Earth. The Sun has an absolute magnitude of 4.83, but due to its proximity, it appears very bright with an apparent magnitude of 26.74. The Sun orbits around the center of our Milky Way galaxy at a distance of about 24,000 to 26,000 light years and completes a revolution roughly every 225 to 250 million years. Since our galaxy is moving at 550 kilometers per second relative to the cosmic background radiation toward the constellation Hydra, the Sun's terminal velocity relative to the cosmic background radiation is 370 kilometers per second toward the constellation Cup, or Leo. The Sun is currently traveling through the local interstellar cloud in the local bubble region within the inner boundary of our galaxy's Orion arm, formed around 4.6 billion years ago. The Sun is currently a main sequence star, and it is expected to remain as such for about another 5 billion years. After that, it will expand into a red giant, shedding its outer layers to form a planetary nebula and eventually contract into a white dwarf. Mercury is the closest planet to the Sun in the solar system, positioned at an average distance of about 58 million kilometers from the Sun. With an equatorial diameter of 4,879 kilometers, Mercury is only 0.383 times the size of Earth, making it the smallest planet in the solar system. As a terrestrial planet, Mercury's surface is composed of rocks and impact craters. Due to the Sun's gravitational pull, Mercury has an extremely short orbital period of 88 days and a rotation period of 58 days. Mercury has nearly no atmosphere, and its surface temperatures are extremely extreme, reaching 700 K during the day and dropping to 100 K at night. The planet possesses a weak magnetic field and a sparse atmosphere formed by solar wind, resulting in a tail. Structurally, Mercury is the densest planet in the solar system, comprising an iron core, a silicate mantle, and a rocky crust. The core constitutes 42% of the total volume and is believed to be in a molten state. Being the least inclined planet, Mercury experiences minimal seasonal variations. Owing to its proximity to the Sun and short orbital period, observing Mercury from Earth is challenging. It is visible only during the morning or evening when close to the Sun and exhibits phenomena like elongation and greatest eastern elongation when farthest from the Sun. Mercury has been a challenging target for exploration, with only 3 spacecraft visiting it so far. The Mariner 10 mission in 1974 and 1975 conducted 3 flybys, capturing images of 45% of Mercury's surface and measuring its atmosphere and magnetic field. The Messenger mission, launched in 2004, performed 3 flybys from 2008 to 2009 and orbited Mercury from 2011, imaging 100% of its surface and studying its atmosphere, magnetic field, and internal structure. The joint European Space Agency and Japan Aerospace Exploration Agency project, Bepi Colombo, launched in 2018, is set to enter Mercury's orbit in 2025 for further exploration. Venus is the second planet in the solar system, located at an average distance of about 108 million kilometers from the Sun. As a terrestrial planet, Venus shares similarities in size and structure with Earth. However, its surface is extremely hot, with high pressure, and its atmosphere is primarily composed of carbon dioxide. The surface temperature of Venus is approximately 462 degrees, making it the hottest planet in the solar system. Venus's orbital period is 88 days due to the Sun's gravity, which is very short compared to its rotation period of 243 days, with a unique retrograde rotation opposite to the direction of its orbit around the Sun. This means that a day on Venus is longer than a day on Earth, and the Sun rises in the west and sets in the east. About 96.5% of its atmosphere consists of carbon dioxide, while the remaining 3.5% is mostly nitrogen. Venus's thick atmosphere creates a greenhouse effect, trapping solar radiation and elevating temperatures to extreme levels. The atmospheric pressure on Venus is about 90 times that of Earth. The internal structure of Venus is estimated to be similar to that of Earth. Additionally, the core of Venus is believed to be in a molten state. Venus has the most tilted axis, approximately 177 degrees, among the planets in the solar system, and has virtually no seasons. Observing Venus from Earth is challenging due to its proximity to the Sun and short orbital period. It is visible either during the morning or evening when near the Sun, and exhibits phenomena like elongation and greatest eastern elongation when farther from the Sun. Thank you for watching.